Okay, a good Friday morning to all of you. Welcome to our final class for Similarity and Transformations. This one will be short. I am simply going to be talking about the final review and then reviewing what still needs to be handed in for this unit. With no further ado, Similarity and Transformations final review. Write all of these down. Page 377 is where the review begins. Number 2 and 6. Page 378, 8, 9, and 12. And then page 379, 14, 17, and 19. And all told, this will be worth 25 marks. Now I'm going to give you a minute to write these down before I go over all of these exercises. So I'm going to give you about 30 seconds to get the questions and the question numbers written down. And write them down. And I'm going to give you 9 more seconds. What's the 9? That was enough time. All right, let's have a look. Page 377, number 2. Draw this pentagon on 1 centimeter grid paper, then draw an enlargement of the shape with a scale factor of 2.5. Make it on the grid paper, enlarge it by 2.5, and you're done. Just make every line 2.5 times longer than it already is. I don't care if you use the 0.5 grid paper. It doesn't actually matter. Use the 0.5 and count each square as 1. That's fine. Okay. It's most of the 0.5 that we've been using. So yeah, if you want 1 centimeter grid paper, well, hey, it's on the internet. You can print off a sheet, but I'm totally okay with you just continuing to use the 0.5. Number 6 on 379. There we go. There's the original shape. Figure out which of these 3 is similar to this one. Only one of them is. Which one is it? You need equal angles and you need proportional sides. They've all got 2 right angles on the bottom, that's obvious. So obviously the ones that are at play are the ones up here. Or you can check the proportionality, like the sides are supposed to all be enlarged by the same scale factor. Like let's take this one and this one. 3.5 times 2 equals 7. That means every enlargement from this shape to this shape should have been enlarged by a factor of 2. By multiplying, by doubling. And if it wasn't, then they're not similar. So you need to find the one where every side was enlarged by the same. And once you have that one, good to go. I would do that as opposed to measuring angles, but that's up to you. I mean, obviously, you've got right angles here, so then you're just going to measure here, 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 and compare. If you want to do it the protractor method or the proportional sides method, doesn't matter. They're both going to give you the correct answer. Flipping over to page 378. First one we're doing there is number 8. And for number 8, we're dealing with 2 quadrilaterals that are similar. They are already similar. We don't have to determine that they are. Calculate the length of PN. So here we have an unknown side. And we have the side that's proportional to it, which is UT. So, how do you know what to multiply? How do you know what the enlargement was here? From this to this? Well, you take 2 sides that you already know, such as the 2.4 and the 3 right here, by how much was the 2.4 enlarged to make the 3. Once you know that, you take this number, multiply, there's your side. And the other one you're supposed to find is side TS, and that's over here on this shape. So this will be the same factor. You only have to find the factor once, right? Because they're similar, so it'll be the same factor each time. The corresponding side is 3.5. Just divide by the scale factor. Simple enough. Yes, no, maybe so. Again, the advantage here is I'm talking about every question. So you can always go back to this recording and pause it in the appropriate place when you're doing a certain question and see what Crazy Mark talked about. Determine the distance across the pond. Ari uses this diagram. What is the distance? Here, D. So we have we have this side and this side corresponding, and we have this side and this side. So how do we do this? By how much was this enlarged to make this? And once we know the factor, we can do it here. Are we multiplying or dividing once we have the scale factor? Well, obviously this side is getting bigger. We can figure out the rest. Yep, and we definitely did this type of triangle question. So you can certainly even go back and look at what we did if it's fuzzy for you. Which of these traffic signs have line symmetry, and how many lines of symmetry in each case? They don't all have line symmetry. It should be pretty obvious which of them doesn't. If it's not, then, well, I don't know. There's one of these can obviously not be divided in any way so that it would be equal on both sides. Hint, hint. Maybe the one with the writing on it, perhaps. Could it be that one? Yes, perhaps. It's pretty hard to split, you know, some of those letters if you're only making one line so that they're going to be equal. Pretty tough to do. Going down the middle of the sign there. Yeah. Different letters on both sides. Anyways, identify whether or not it has line symmetry, and then how many lines of symmetry does it have. You can do a sketch, or you can simply write it out for each one. That's up to you how you do that part. Onward to page 379, number 14. Rotational symmetry of each shape. What is the order? In other words, how many times does it, if you turn it, how many times does it coincide with itself? Now you can see this visually, or you can do a drawing for yourself and spin it round. It's up to you. I'd say you should be able to do this visually. That's what I'm thinking. When you make it, how many times will it coincide with itself when you turn it for each shape? What is the order of rotational symmetry? How do you know? Well, don't worry about that. You either did it with a sketch or you saw it visually. Just tell me what it is. What is the order of rotational symmetry? In other words, how many times does it coincide with itself? And that brings us to number 17. For each diagram, determine whether the two pentagons are related by any symmetry. Describe the symmetry. So they could be a reflection or they could be a rotation. That's up to you to decide. Look carefully. A reflection, they have to be the same distance apart. If they're not, then they are possibly a rotation. And if they are a rotation, take a protractor and check that it works. Here, this looks pretty equal distance coming across the origin here, right? Here we have a space here, but then on the other side there's two spaces. Should be a bit of a hint that that's not a reflection. So you take your protractor, check if it's a rotation, perhaps. They do lie in a straight line. Wonder what that could represent. translate quadrilateral DEFG. This is number 19. As indicated, then draw and label each image. There's your original shape. I would do this 2 separate times. I would make the original shape, make the new one, then I'd go to a new part of my grid, make the original shape again, make the new one again. So here, you take the shape, move it 4 spaces left and 2 down. And you do that for each point, make the shape again. And then, does each shape that you have made, is it line symmetry or rotational symmetry? If it is one of those two, then say which one it is. And if there is no symmetry, say that. Okay? Simple enough. A and B for 19. Those are all the review exercises. Page 377, 2 and 6. Page 378, 8, 9, 12. Page 379, 14, 17, 19, 25 marks. This is a hefty review, folks. So, hand in for marks for this unit. Enlargements, reductions, and triangles. That was a worksheet. 20 marks. Still waiting for that one from some. Yes. Although maybe by the time Friday rolls around and you get this on recording, maybe I won't be waiting anymore. I'm optimistic. 20 marks. The mid-unit review, page 352. Number 1, 2, 5, and 6. 15 marks. And then the final review that we just reviewed, 377 to 379, and there's just all the questions in one long row, which you should have already written down by now. We're going to have a deadline for this unit. Next Friday. You should have the previous 2 assignments handed in already. You should only be worried about getting the final review done. I'm not going to have a recording up on Tuesday, so you'll have most of next week just to get this unit done. Okay? But there's going to be a deadline. Friday, May 15 for all 3 of these hand-in assignments. Enlargements and reductions worksheet, mid-unit review, final review. Got to begin by next Friday, May 15, 2020. The first recording for the circles unit will be the day before, the Thursday. Supposed to be a math class on Tuesday. Not gonna do a recording on Tuesday. I'll wait till Thursday, May 14, 2020. This will be a unit on circles. Thursday, May 14, 2020. The new unit begins. The absolute deadline for this unit, Friday, May 15, 2020. My best advice to you would be is to have everything done before or on Thursday when you're beginning to deal with new stuff. And you should be able to get that done without any great deal of difficulty. You'll have an entire week after this recording to get it all in, and during that week there'll be just the one class. And I'll probably just be a short introductory class. That's it for this. We kept it at 14 minutes. Adios.